Now this is a slightly weird problem because of one thing that you will see once you start problem solving. Again, don't think too much, just start to solve it, okay? So if you want to understand the problem, you actually have to solve it. Solve the problem, I'll give you the answer. Okay, I'm going to give you the answer. It's actually from speed and distance, the boat problems. A group of men can canoe, row at 40 kilometer per hour in still water. So that is the actual speed of the boat. Okay, speed of the boat is 40 kilometer per hour. After rowing for 2 hours, the stream flows downhill, and they will take two more. They will take 2 more hours to reach the point. Okay, here there is a problem because they are saying that after rowing for 2 hours, the stream is flowing downhills. That means they are saying that the stream was straight and not flowing downhill, but then after 2 hours, it started going down. So our common sense will say that if the water is falling down here, the water must also be falling down here, moving down here. But see, uh, first of all, the speed is 40 kilometers, and 2 hours will make the distance 80 kilometers. That's a big distance. So the flow will directly won't influence like this, and also this problem is not very an ideal problem. So you have to take it literally. After rowing for 2 hours, the stream flow downhills means only in this part the stream is flowing downhill. In the straight part, it is actually still water. So here the stream speed is going to be zero. Stream is not moving. Here the stream speed is something. Let's call it Vs. So if the boat is going here, if the boat is going here, here the boat only have one speed, that is the speed of the boat. Let me change the V to S. Okay, speed of the stream, and there is nothing to influence here. So we know that speed is equal to distance by time, or speed into time is equal to distance. So if 2 hours this boat is rowed at the speed of 40 kilometer, then the distance covered will be 40 into 2, 80 kilometers. So this distance is actually 80 kilometer. Now after this, what is happening is that here the stream has some speed. Okay, we don't know what that speed is, but that speed has an influence, because once the boat reaches here, then its speed is going to increase. First, the speed of the boat is going to be there, on top speed of the stream is also going to be there. So from here, from this point till here, this is the speed, and 2 more hours to reach the point, and they are rowing for 2 hours. So again, speed into time is equal to distance. So let's call this distance as d down, or let's call it d slope, ds. So that's d slope is going to be speed of the boat was 40 kilometers, and the downhill speed of the stream, I don't know that, I'm going simply going to ss into 2 hours. So this is this distance. We don't know the value of this thing, right? Let it be like that. The remaining part of the problem, on the way back the same route, the time taken is 2 times the time taken onward journey. So onward journey, well when we are going down, it took 2 hours in this part. Okay, it took 2 hours in this part and another 2 hours in this part. So the total time taken was 2 plus 2, 4 hours. Now on the journey back on the same route, the time taken is 2 times the time taken onward journey. That means while going back the same route, um, while going back the same route, they took double this time. That is 4 into 2, 8 hours. Interestingly, here also the scenario is same. Only here the flow is there. Speed of the stream. Here there is no flow. So here there is no flow. That means the boat is going at the constant speed. From this point till here, starting point, the boat is going at the constant speed of this thing. And we already know this distance, that is 80 kilometer. 80 kilometer at the going the speed of 40 kilometer per hour, it will actually take 2 hours. There is no change. 2 hours forward, 2 hours backward. The only that basically means out of the 8 hours, 2 hours is consumed here, and in this part we are consuming 6 hours. Now, what is happening here? The boat is actually going uphill. Okay, the guys are trying to row the boat this way, but the stream is trying to push it away. So the effective speed uphill is going to be speed of the boat minus speed of the stream. That is the speed. And we again, the speed into time is equal to distance. So the time taken for here is 6 hours. Speed into 6 is going to be, the distance is not going to change, right? That is still same, ds. Okay, and for sb, speed of the boat, I can replace that value with 40. Now if you look at the two equations, you will find this distance is ds, this distance is ds. We have two equations, both are same distance. If I can equate them, distance is equal to, this part is, that same thing will be equal to this part also. Now if you solve it, you will find the speed of the stream. What is the question? What is the speed of the stream? That itself is the question. So you just have to solve this part. I'll take the 2 to the other side. I'm going to get multiplying it inwards. This to the other side and this to the other side. I will get T, right? Speed of the stream is going to be 20 kilometer per hour. So that's answer. Now if you assume, if you, instead of doing this thing, if you have assumed all this place have the same flow, then that answer is not there in the option. So this is not an ideal case. This is more or less similar to the real life scenario. So that's it, guys. Thank you.